好，各位听众朋友，大家好，欢迎大家来到今天的 DBT Meetup。今天我们是30场，第30。好，今天我们邀请到 Josh Will 来帮我们讲。好，那我们要先介绍一下场地。好，我们这个是台北 DBT Meetup，然后我是今天的主持人 Lawrence。然后好，第一件很重要的是，有没有谁还没有加入我们的 Slack 的？好，我知道，也许你还有千百个理由，你的手机没有灌 Slack， 你的电脑没有灌 Slack， 然后你的 QR code 的那个程式坏掉了。好，拜托就当被骗扫一下。好，因为你加入了以后呢，你就可以找到那个 local-taipe， 然后来到这个社群呢，来到 local-taipe 以后呢，你就可以问问题，然后不要担心，就算有人写英文，你写中文，我一定会回你的。然后你一旦进入了这个 Slack 以后，你之后在这个 DBT 遇到任何问题，你都可以找答案。怎么找呢？你就是到搜寻的地方，例如说就找一个什么 tool metabase， 答案就出来了。所以呢，加入这个好处多多，而且又可以交朋友，好，应该是啦。然后，所以大家就当被骗，加入一下。好，然后呢，大家有没有在用 DBT 的？有的话，或者还没有开始的，其实可以考虑 DBT Cloud 的。然后也是扫一下，就是那个就可以看一下。那 DBT Cloud 有什么特别呢？就是由于 DBT 官方赞助我们零食饮料，我们要大家帮忙宣传一下。DBT Cloud 就是说，你如果用它 Open Source 的版，你就直接安装在你的电脑上或者你的 server 上。可是你用 DBT Cloud 的话，就有 UI 了，然后而且这个 UI 还整合的不错。好，那所以这个就可以考虑看看，而且它就会自动帮你升级啊。嘿。好，那这本日的 agenda， 然后现在已经是开始过完 welcome 的时间。好，那个零食饮料大家可以自取。好，所以就准备开始介绍啊。OK， 好，那接下来会中英并成，因为今天的那个 talk 是英文的。Next, I will be using English and Mandarin to introduce. And today's talk is in English. 首先我们要来介绍那个 Josh Wells， 他是 DuckDB Adapter 的 contributor。所以如果说你现在可以用 DuckDB 的话，那你就知道要感谢谁了。好 ，Josh Wells is the DuckDB's adapters contributor. So if you are using DuckDB now, you know who to thank. And 好，那接下来要稍微介绍2个观念。好，第一个问题是说，好，在介绍观念问大家一个问题：有没有人知道说那个全世界部署最多的 SQL database 是什么？快问快答。哦，答对了 ，SQLite， 没错。那为什么呢？好，其中一个理由应该是因为它是 embedded 的。Do everyone know that what is the most deployed SQL database in the world? It is SQLite. Why is it most deployed? Because it is embedded database. This is one of the most important reason. 那请问一下，大家知不知道什么是 embedded database？ 不知道举手，不清楚这个概念的举手，清楚的举手。好，正如正常。好 ，OK。Do everyone know that what is embedded database? If you know, raise your hand. If you don't know, also raise your hand. As usual, there will be no one raise your hand in Taiwan. This is our tradition. OK， 好，那个这边很快速的用一个比喻，让大家可以对 embedded database 多一点了解，就是说，假如说各位有小孩，好，我知道有人还没有结婚啦，就知道当我很老。好，那就说你有一个小孩，他今年5岁，然后他不会算数学，然后他还是跟你玩超商跟店员的游戏，就拿计算机按。好，有一天他会算数学，终于会算加减乘除了，所以呢，你就可以视为说他把这个计算机的功能 embedded 到他大脑里面，所以 embedded 是一个很重要的概念。OK，Let me introduce the idea of embedded to everyone to help you understand how great DuckDB is. Imagine you have a 5-year-old child. Okay, I know some of you have not get married. That's fine. Don't worry about it. And she cannot calculate plus, multiply, divide, minus. But she can still play as a register in the supermarket, play the game, because she can use the calculator to press and calculate the answer. And when she grows up and she finally learned how to do the basic math, this is the time she embedded the calculating feature into her head. So this is the importance of embedded. Okay, let me introduce our speaker.
Thank you. Thank you so much, man. Thank you, everybody. Thank you. I appreciate it. I have never given a talk. Ooh, I'm not going to knock this over. Okay, I didn't. Woo, thank God. That would have been really embarrassing. Like I kick off the talk and I just go flying across the. I have never given a talk in English to an audience where I'm assuming all of you speak English most likely better than I do. But is there anything I can do to make this easier if I use idioms and things that don't, is there a thing that people do? What do people do? Please. Yeah. Is that okay? Please. Yeah, exactly. I try to be fairly attuned to my audience and stuff, but I'll do my best here. All right. So yeah, you heard a little bit about me in Mandarin as well as English. This is a little bit more about me. So I have done a lot of different things in my career. I worked at Google a long time ago. I worked at Cloudera doing big data, 1.0, Hadoop and Spark and all that stuff. I still use Spark every day. And so Datology is a data curation company for building foundation models. So I basically run Spark and Ray data pipelines every day. Well, not right now, I'm on vacation, but every working day, over 10, 20 terabytes of data, text data, image data. So I still do like big data stuff, I guess, in some sense, right? Despite that, what I'm here to talk about today is basically the exact opposite of that, which is my work on dbt-db, which is the very best dbt adapter that you can use. And do I have any dbt-db users here? Has anyone ever used it before? Oh, a few. Oh, thank you very much. I appreciate that. Thank you. And you all obviously agree with me that it is in fact the best. It's not a lot of you can't tell on the screen, but everyone in the room is nodding vigorously. So yes, anyway. And then additionally, I am an angel investor. And I am an angel investor in at least a few companies I will talk about today. And I generally like to tell people when I am giving talks that mention companies I've invested in, that I have invested in them, and that thus I have a financial interest in what I am saying, and therefore nothing I say should be treated as trustworthy or anything like that. Because again, I'm just in it for the Benjamins. So yeah, I'm an angel investor in DLT Hub, DBT Labs, Tabular, which is most recently joined Databricks, MotherDuck, and like 40-ish other companies that I will, not really be talking about today. So yeah, okay. The subject of today's talk, this is a new talk for me, and I like when I'm doing a new talk, I like to sort of take it out and do meetups and like workshop it and figure out what's a good message with it. And so that's what I'm trying to do today. And the thing I want to talk about right now is data quality. Data quality. What do we talk about when we talk about data quality? Most of the data engineers I know, analytics engineers, have some kind of data quality tooling. They obviously have DBT tests. They may have, Monte Carlo or Anomalo or any other sort of data quality tool that they use on top of it. But in my experience, what most of them mean when they say data quality is generally situations where an upstream engineering team changed something in their system and didn't tell the data team about it, roughly speaking. Most data quality problems are really engineering communication problems. Occasionally things break, right? Occasionally we introduce bugs. Occasionally like things just go wrong. This is the world. This happens, right? But a lot of the time what we're talking about when we talk about data quality is upstream engineering teams don't care about what happens to data before it goes into the data warehouse. They have no visibility into it, and they basically don't care. Okay, that's sort of the problem I want to talk about today. Data teams are not the only teams in the world that feel like upstream engineering teams don't care about them. This is not a problem that is unique to data in any way, shape, or form. Over the last few years, there has been this movement, primarily in the DevOps community, called Shift Left. Shift Left here. The idea of Shift Left is to move sort of more and more of the testing, verification, security, operational workloads that generally happen much later in a software development lifecycle, like generally things that happen, things that we only check for after we've released some software, or something where like things are now in production and we want to look for things. We're trying to there's this movement to sort of move those checks and move those verification steps much, much earlier into the software development lifecycle. Ideally, we want to move them into the sort of stage where developers are actually coding systems wherever possible, so that essentially we want the security checks to be done on the application as the developer is making it. And if we can't do that, then we at least want these security checks to happen as part of unit testing or something along those lines. We want to be constantly checking for these sort of deployment issues, security issues, and yes, data quality issues as early as possible in our sort of software development systems. That's sort of the overall notion of something called Shift Left. Unfortunately, what sort of often happens is when a sort of term like this is created, software vendors grab it and kind of take it over, and they use it to sell things. And that's more or less what's happened to Shift Left. Shift Left has come to mean to a lot of software engineers. Shift Left means you, a person who is not a software engineer, wants to move some of your work onto me, the software engineer, instead of having you do it, right? So I am a security engineer, but I don't really know anything about how the back-end software system works. So I want you, software engineer, to use this tool that will basically do my job for me. That's more or less it. And so I, as a software engineer, and I guess if I didn't say this, I've done pretty much everything you can do in software engineering, I guess, at this point. I guess everything except for front-end engineering, more or less. Front-end engineering is the only thing I have not done a lot of. But I have done back-end engineering. I have built search indexes. I have written a lot of data pipelines of all stripes and all places and things like that. So I've done lots and lots of different stuff. And nothing really bothers me as a software engineer as when someone says they want to shift left something onto me, right? It's drives me crazy. And so the goal of my talk today is, if you want to shift things left, and we should be shifting data quality left, what I want you to do is shift yourself left. I want you as a data engineer, analytics engineer, whatever, to broaden your skills and sort of come join the ecosystem of tools that other software engineers use to do this sort of early verification, unit testing, functional testing, integration testing with your data pipelines as early as possible in your development workflow. That's really what I want here, right? So I say things like this, right? And the problem I run into with this pitch for most data engineers most of the time is that data engineers are deeply wedded and deeply married to their data warehouse. They love their data warehouse. Their data warehouse defines them as a person, as a profession, all that kind of stuff, right? I am an expert in Snowflake. I am an expert in BigQuery. I am an expert in Spark. I am an expert in Teradata. Whatever it is you are an expert in defines you as a professional, defines you as an engineer. And this is not unique to data engineers in any way, shape, or form. I mean, front-end engineers are enthralled to the browser. Mobile engineers are enthralled to iOS or Android or whatever. Back-end engineers are, in love with their online, Postgres or MySQL or MongoDB, whatever their transactional processing system is. That's the thing they love. All engineers define themselves in terms of whatever monolithic entity that they worship. The sort of virtue, though, is that what these other engineers have, the data engineers have not historically had, is the ability to shrink their monolith down into a tiny little thing that can fit, I guess, in a 5-year-old's head, to use a good example, right? They can use like tools like Puppeteer for browsers, right? Or emulators for iOS and Android, or in-memory MySQL systems or Postgres systems or whatever, to shrink down their system, the system they work on, into something small that is designed to play nicely with everyone else's stuff so that it can all be tested together. And historically speaking, for data engineers, that really hasn't been true, right? You can't shrink Snowflake down into a little tiny container. You can't, you can try to shrink Spark down into a tiny container. It's kind of, you can kind of do it. It sort of works, right? But that's historically been the challenge, is the data warehouse was not something that was, it was designed for scale. It was designed to be big. It was designed to be powerful. It was not designed to be modular. It was not designed to be like something that was play nicely with others. It was kind of the center of its own universe, right? And so that's the sort of challenge we have to fix, the thing we have to address to make this possible. These ideas are not necessarily new, okay? So because the data warehouse is so big and so monolithic and so inflexible, people have come up with ideas and ways and tools to basically emulate some of these ideas around testing and shifting things left without actually having to shift the entire data pipeline stack or the entire data warehousing stack left. And the most popular of these is something called data contracts. Do people here know what data contracts are, roughly speaking? People heard of data contracts? Not everybody, few people, right? Okay. A data contract is really just like a schema definition, essentially. That's really all it is. It's a schema definition. We're going to define some set of tables in the upstream system, and we are going to say, these are going to be the names of the tables. These are going to be the data types the different columns have, all that kind of stuff. And we promise we're not going to change them without telling the data team. That's pretty much it. Whenever we add a new sort of table or add a new column to a table, we update the data contract first, and then the data contract sort of runs on the change and verifies that, yes, this isn't correct, and this is a data type the data warehouse knows how to support, and all this kind of stuff, right? And this, again, is not a new idea, right? If you use like a statically typed programming language, you are basically operating under this contract regime. There are types, and they have names, and you can refactor them, and you can make guarantees about them, like all that kind of stuff, right? And that's essentially the same idea, data contracts between an upstream production system and a downstream data warehouse set of data pipelines. We define some data contracts. I think dbt introduced data contracts recently. Like there's now in the dbt mesh or whatever, there's a data contract sort of construct along these lines. But is it not an open source? Is it only in dbt cloud? That's what it sounds like, right? Something like that. Okay. But the idea here is fairly simple. It's like, this is a entity, like a table. This is the set of fields that we'll have. This is what their names are. This is what their types are. And this will be enforced. We will verify this. We will not make changes upstream without making these changes as well. And this is great. This is a very good thing. This is like a very positive step in the right direction. But it's also not sufficient. It's not sufficient to me. And the reason is because there are a lot of changes, a lot of situations where we break things just by like changing something upstream and not telling anyone downstream. But that's not necessarily limited to types. Like using a statically typed programming language does not mean you do not need to do unit testing or integration testing between different systems. You should still run the business logic and ensure that it works across these different systems. And so that's not something data contracts do. Data contracts are sort of static type definitions. They don't verify that the logic actually works correctly upstream and downstream together. And so that's kind of what I want to change. So what I'm talking about today is inspired by a long list of talks and sort of ideas and things like that. So I'm not like the only person talking about this. And I threw a list of them together here. There's the Big Data is Dead blog post by Jordan Tigani over at MotherDuck. There's the Future Roadmap of the Composable Data Stack by Wes McKinney, who many of you know, he created Pandas, worked at Voltron for a long time, and he's now working at Posit. The local data stack is a really sort of cool set of ideas from a bunch of folks from the dbt-duckdb community about combining DLT and Dagster and dbt into something that's designed to run like entirely locally, like a whole data stack that has no gigantic data warehouse at all, actually. And then most recently, the excellent DuckDB is not a data warehouse by my friend Chris Riccomini, who is, I don't know, I don't really know what to call Chris. I think he would take offense if I said that he was a venture capitalist, but he's effectively a venture capitalist. That's effectively what he is. He's just a very, very smart engineer as well as a venture capitalist. Okay. And so that was sort of I read these things and they were the inspiration for me in thinking about this and talking about this. And so I sort of tried to put something together that was like my own riff on these same set of ideas. And so what I want to walk through now is a sort of set of things that I would like you to try to do. And I feel like this is the right audience for what I'm saying. The kind of people who come to DBT meetups are the kind of people that I want to be talking to, right? Because it signals to me that you care. Like basically, most people, like, you know, they do their jobs and it's fine and they get their paycheck and they go home and stuff like that. So they go play with their kids. It's great. There's nothing wrong with that. But there are some people who want to be great at what they do just as a matter of pride. Because what I want to talk you into is hard. This is not easy to do. This is going to be challenging in a few different dimensions. But I think that doing it will make you a much better engineer. And I think it will make you a much more valuable teammate to the rest of your engineering team. And so that's kind of what I want to pitch you on today. The first step in this journey is containerizing your data pipeline. Containerizing your data pipeline. Do folks know what I say when I say container? It's this thing called Docker, right? Docker defines a container. A container is just a software abstraction that's like a Python runtime and a file system and a bunch of dependencies and other things like that. And so the first step in this journey is taking your data pipeline, wherever it is, whatever Git repo it's in, figuring out all of its dependencies and packaging them together into a single sort of atomic software unit that is designed to run anywhere, on your laptop, on an EC2 machine, in a CI/CD system, like as a GitHub action, any of these kinds of things. That is the first step. And this is probably the hardest step, because what this means is the data pipeline can't have any external dependencies. Anything that's not in the pipeline, anything that's not in the container, you can't use. So in particular, you can't use BigQuery. You can't use Snowflake. You can maybe use Postgres. Postgres can probably squeeze into the container. You can definitely use DuckDB. You can absolutely use DuckDB, because DuckDB is, again, embedded and designed to run in process as small as possible. If you are using a non-DuckDB data pipeline for whatever reason, and that, again, you are almost certainly using a non-DuckDB data pipeline, doing this will require figuring out which parts of your pipeline are using like features that are unique to Snowflake or unique to BigQuery and abstracting them away via macros or SQL glot or whatever other sort of tooling you want, such that your data pipeline could run in a database independent way. So that it could run against DuckDB, so that it could run against Snowflake, so that it could run against any database you want. That's like challenge number one. It's not easy, but it's also not that hard. Like all of these databases derive from Postgres, right? Everything flows from Postgres. So the bits and pieces of your pipeline that are really like unique and specific to these different data warehouses that aren't abstracted away by dbt turn out to actually be fairly small in the grand scheme of things. Okay, this is sort of challenge step one. Challenge step two: understand how the rest of your engineering team does CI/CD. CI/CD stands for continuous integration, continuous deployment. And it's just kind of a catch-all term for saying integration testing. When you have multiple different software systems and you want to ensure they all work together before you push them out to production, how does that work at your company? How do you do that? Who does that work? This is hard because it requires talking to people. So like this first step requires talking to no one. You can just kind of go off in a corner and do this by yourself. It's sort of like a fun, kind of like Rubik's Cube like puzzle. Like it can just be sort of a fun, like, interesting activity to do. This one is harder because it requires talking to people. It requires learning from them how they do their jobs and how things work and how a containerized data pipeline can run inside of the systems that they have created to do different things. I feel very strongly that data engineering teams are engineering teams, first and foremost, right? Every engineering team that has a dependency on any other engineering team has the right and the obligation to integration test that upstream system with changes that impact them. That is the way the world should work. Front-end teams have every right to ask the back-end team to ensure their APIs work with front-end changes and vice versa. Data teams are no different in this regard. It's exactly the same, right? Everyone should be able to work together in the same like virtual environment that any other engineering team should use. This is a weirdly controversial idea. I don't understand why, but we can talk about that a bit after, I'm sure. All right. And then steps 3 to infinity. Ask lots of questions. We happen to be living in the greatest era ever for asking stupid questions. This is the best ever because we have the dbt Slack and because we have the DuckDB Discord and we have Claude and we have Gemini and we have OpenAI and we have GitHub issues, right? You can become an expert on virtually anything you want if you know what the right questions to ask are, right? I like to say that like using Claude and using Gemini and using ChatGPT is like having instantaneous access to the world's worst X for whatever value of X. If I want to talk to the world's worst anthropologist, I can ask Claude. If I want to talk to the world's worst economist, I can ask ChatGPT. Like instantaneous access to the world's worst X for any value of X is tremendously useful because it turns out a lot of the time, the world's worst version of something is perfectly adequate for what you're trying to do. So if you need instantaneous access to the world's worst ops engineer, they're right here. You can ask any of them. And if none of them work for whatever reason, I am the second worst ops engineer in the world. And you can find me in the dbt Slack and you can find me in the DuckDB Discord. So I'm at your disposal for this sort of stuff. All right. When you do this work, what I think you're going to find is that data ingestion from the upstream system into the downstream containerized data warehouse is the key to making this whole system work. And so one of the reasons I like DLT and one of the reasons I invested in DLT is because DLT is just a Python library. That's it. It's not a framework. It's not a cloud service. It's just a Python library. That's all it does. It's a Python library for moving data from upstream source systems to downstream data warehouses as quickly as possible in a consistent schema that does all of the sort of boring, tedious schema evolution and nesting and unnesting of data. It does all that stuff for you. So you don't have to worry about it. So you don't have to do it. And so ingestion is sort of like the binding between the upstream integration tests and your downstream data pipeline tests. And that's why I like using DLT because it like makes this stuff easy to do. It makes it possible in a way that Fivetran and sort of other like heavyweight systems don't really make possible. Yeah. All right. The hardest thing about getting started is getting started. And so I created a GitHub repo. So this up here, this is github.com, jwills, shift yourself left, where I created a simple like web application and a simple dbt-duckdb project. I containerized all of it. It's all in Docker containers. And I created an integration testing harness so that you can test the upstream web application and then feed the test directly into the test for the downstream data pipelines. It's the simplest possible example I could think of that would illustrate these ideas in a way that you can like copy paste into Claude and ChatGPT and all that kind of good stuff and like get answers to things when you see something and you don't understand it. It's designed to be just like the absolute bare minimum you would need to make something like this work. And that's it. That's the challenge I have set for you. Like the best way to sort of solve the data quality problems that sort of plague your downstream data pipelines is to prevent the bad stuff from getting into production in the first place. And the best way to do that is to run integration tests, is to ensure that before a backend change is made and pushed to production, the downstream data pipelines will still work once that change is made. And kind of like more than that, what I think you will find is that when you free your mind in sort of the matrix Morpheus kind of sense of the term, from the constraints of the data warehouse, when you're not sort of stuck thinking about data pipeline problems purely from the perspective of Snowflake or BigQuery or whatever, you will find there are lots and lots of places in your system where data pipelines can be really, really helpful. And if you didn't need the data warehouse at all to run them, you could have a lot more impact on like your users, your company, sort of all the things, because the stuff you know how to do is really, really valuable and really, really powerful. And it really shouldn't be trapped in these big sort of vendor-based data warehousing systems. That's kind of my thing. Yeah, and that's pretty much it. So thank you all very, very much. And I'm happy to answer questions and blah, blah, blah. Thank you. Yeah.
And people who are online, we're also welcome to unmute yourself.
Hey, how's it going?
Actually, this question is I think I want to ask for people who are not expert enough, because I found that you use an idea that you think I think you probably consider it really simple. You say injection is really important.
Yes.
So
yes,
may I ask you to explain injection a little bit more?
Ingestion, absolutely. Yeah, totally. So, man, I think this is like, you ask a very simple question, and I'm going to give like a really long-winded answer that goes on for a while because I can't help myself. I'm really sorry about that. No, that's not. You want to encourage that? That's not okay. That's fine.
I probably will cut the time if like it's
If
too
it gets out
over.
of
But
control,
and
I
also
appreciate
I want
that.
to ask about like what is DLT as well. And
Oh, what is DLT?
And
Okay.
yeah, and also there's some
Yeah.
question
All right.
afterwards. So.
Afterwards, awesome. All right. So I think of data systems as having four primary components. Okay, four sort of jobs to be done. First is ingestion, and that is typically Fivetran, or Stitch, or DLT. Ingestion is there is data in Salesforce or in my upstream production data warehouse or in Kafka or in some log system somewhere, and I need to get it into the data warehouse. And I need to do that in a way where I don't break the upstream system. Like I don't just sort of turn on a fire hose and just like grab all of the data. And I need to do it in a way where I am mindful of changes, that I want to pull as little data as possible. I want to have as little impact on the upstream system as possible. And it really is like the very first step in any data system, because if you don't have the data, then there's really like nothing else to do, right? Downstream of that, there is sort of query processing, like storage, storing the data, processing the data. And that is typically, Snowflake, BigQuery, Databricks, like what your main sort of data warehouse. And then of course there's the transformation, the DBT stuff, and then the BI stuff, like the Looker or Tableau, whatever your BI tool is, right? Those are sort of the four main stages here. Ingestion is the key to what I am talking about here, because pretty much all of the ingestion systems I am aware of are kind of giant monolithic things. Like Fivetran is a cloud service that I cannot compress down into something tiny that I can run inside of a container. I don't think Fivetran would like that if I tried to do that, right? The reason I like DLT as a tool, as a software engineer, as I've gotten older and have suffered more and more as a software engineer, I find myself liking frameworks less and less and liking libraries more and more. I like libraries that are small, that are designed to do what I tell them to and nothing else. That's like broadly my preference. I maybe make an exception for DBT. DBT is a little more frameworky, but it's a very useful framework, and so I can forgive it its frameworkness in some ways, right? But for what I'm talking about here, the reason it's okay for Fivetran to be a cloud service is because Fivetran only does one thing, which is move data from production systems to the production data warehouse. That's its only job. What I'm talking about here is having sort of a data ingestion system that can work in lots of places. It can work in big places like giant production systems, but it can also work in very small places, like say inside of a container running in your CI/CD system that needs to run in just a few seconds, not minutes or hours or whatever, like nothing like that. That's sort of what I talk about. The hard part, like what I think people will find is like, you know, SQL is SQL. It's not that bad. Like translating SQL from one database to another, there's lots of great tools to do it these days. It's not really a problem. It's like easy to do. Making your ingestion system fast, but also consistent across all these different environments, consistent across your testing environment, consistent in your production environment, is a much harder problem to solve, to make something like what I'm talking about into a reality, just because there are so many different upstream systems that you have to be mindful of. Yeah. Is that anything like an answer? How was that on time? Was that okay?
Yeah,
Okay.
sure.
Yeah.
So there's a audience check
Cool.
online, so I will read his question, or her, I don't know. Here is a question about how to measure the data quality. Is there a common or recommend metric for measuring the data quality?
Ooh, that's a great question. Not that I am aware of. I mean, I generally like measured my data quality in like the number of like terrifying late night direct messages I got on Slack from the CEO. That was generally my metric. If the number was 0, that was good.
Yeah.
And if it was,
if it
really
was practical metric.
it was a very direct metric, right? That was about as bad as it got. I guess I was fortunate. It was funny to me, like when I worked at Google, the kind of integration testing systems I'm talking about here were like completely standard. That was how we did everything, because, you know, the downstream data pipelines, they did our billing. They did our machine learning models for click prediction. They did everything. And so like we couldn't ship an ad server or a web server that broke the downstream data pipelines, because it would break the business. And so I kind of got used to having these kinds of systems. And then when I left and I went to Slack, and at least at first, like at Slack, the data pipelines, you know, they weren't doing anything super important, right? I was surprised that systems like this didn't exist. And so introducing like a data contract system was basically the very first thing I did at Slack. But I was always frustrated that I couldn't run this kind of integration testing because nothing like DuckDB existed. So I couldn't do this. Like DuckDB, DLT, DuckDB, and then dbt is kind of a standard tool for transformations. It makes something like this possible without a ton of bespoke custom engineering effort like we had at Google. It was not something I could have invested in a reasonable way back in like 2015 or whatever. Yeah. It's a great question. Thank you. Yeah.
Is there anyone want to ask question? Because I have two. 那我给你们点时间准备哦。好 So I have two questions.
Two questions. Like, these are your questions, or these are people? Okay.
You mean my question?
I mean, it's fine if it's yours. I'm just curious.
Okay.
That's all.
No. I really have two questions. So one question is about because when like Alex, like he's the the DuckDB passionate evangelist, and and he like forced everyone who joined that meetup install DuckDB directly in the in their computer.
That's great.
Yeah. So I didn't understand like why he's so passionate about DuckDB, and I realized probably people will think about it is like easy. It's simple, and you can run on your local, because I don't have a concept about like running memory or something. I don't, I can't tell which one is which anyway around my computer. But I feel like you say another concept, like you saying that you want to have integration testing with everything in a single. So
yes,
is that the purpose for DuckDB? Like, is that the purpose for integration testing?
No, I mean, it's a great question. I don't know what the purpose of DuckDB was.
Okay.
Like, I really don't. I mean, I think, when I first discovered DuckDB in 2020, actually during the pandemic, when I had a friend of mine who basically asked me, he's like, is there something like SQLite, but for analytics?
Oh, okay.
And I was like, well, that's a really weird question. Why would you ever need something like that? That doesn't make any sense. But I went looking for it. I mean, at the time he was building a sort of a local, like a desktop BI tool that was very cool. And so he was building like a visualization layer and was kind of basically writing essentially a database locally, like Tableau did, like lots of other people did. He's like, I don't want to have to do this. Is someone doing this for me already?
Okay.
And it turned out the answer was yes. It was DuckDB.
Okay.
When I first picked up DuckDB, I just thought it would be a fantastic teaching tool. Like one of my great frustrations is that, you know, a lot of software engineering and in particular data engineering, the only place you can learn how to do it is on a job. It's not really something that can be taught in school, right? And that's still true to a large extent. But it's kind of like if you don't have a cloud data warehouse, how can you really learn how to do this stuff? Even, you know, like you could run Postgres locally, but even that is like a lot to ask of people. Like running, you know, you can run Postgres. You can do it. It's not the easiest thing in the world, but it is doable. And what I loved about DuckDB was like, you know, pip install it, pip install dbt-local-taipei, and like off you go. You're done. That's it. You have nothing else to do. You can just immediately be like, you don't have to let these sort of like set up technical issues distract you from the learning of like let's talk about data modeling. Let's model some data. Let's see the trade-offs of different things. Like those were kind of like, that was the skill I wanted to teach. And I didn't want the like set up overhead stuff to get in the way. So that was why I initially created the project. I thought it'd be a really cool way to learn this stuff and teach it.
Then how about like I cannot imagine, like you mentioned about like putting the integration test in your CI/CD or something like that. It feels like if my team like scale enough need to have these kind of testing and all these like CI/CD or like many different tools need to be integrated, then my data set probably is large and probably it's complex. So the purpose to have this testing, like I don't know, like how to like take partially to test or something, like how we take this.
That's a great question. It's a great question. Good testing leads to good design in all of software. Like the reason we do unit testing in software is because we end up with like small functions that do one specific thing that are easy to test. One of the most common problems in data pipelines is trying to think of a way to say this that won't sound vaguely dirty, but I'm failing. Premature integration. People are often joining data sources, joining data from multiple different like independent data sources much earlier in their data pipeline than they should. This is a very, very common problem. Does that make sense? Like imagine you have like a very early part of your pipeline that involves joining data from, I don't know, like your logs system with a copy of your upstream database tables or something like that. And then if either of those systems gets blocked by something, the whole pipeline is stuck because you can't run anything until this join is done very early on. This is a very common design flaw that I see all the time in data pipelines because it's something that's kind of easy to do in a sort of mindless way. And what I like about this kind of integration testing is it encourages a really strong, clear separation between your upstream data sources. It sort of tends to push these joins and these sort of like this coupling of data from different data sources much lower in your pipeline. Because what you want to do is say, okay, I'm integration testing system A. I only want to run the DBT models that involve data from system A. And so if as much of that stuff is like refactored early in the pipeline, I can run it very quickly. Whereas it's basically like I would call it in software engineering a smell test. It's like if you can't break your data pipeline apart into these independent components that have different upstream sources, that's bad. That's a design problem. That's the kind of design problem that good testing is designed to find and fix. Does that roughly make sense? Okay. Anyway.
Can you say more about that? Like how do you measure or like identify there's a mature or like thoughtful design
Ooh,
Or
man, that is a great question. What would be a good metric for that? This is where like I turn into a mathematician and I'm kind of imagining the DAG in my head and thinking,
yeah.
how would I color this graph? Now it's a tree, so I can always two color it. That's fine. That doesn't count. I don't know. How would I measure how late?
Or maybe not measure, just like how do you tell there's something wrong? Just like you saying they're
Yeah.
too early, too early to join different data sources
Yeah,
or like
yeah.
something.
Exactly. The general way I know when this happens is when the entire data, like this is again, because we don't really do this kind of integration testing, we only find out about these problems in production when it actually is an issue. And the main smell is kind of what I said, is like one of the upstream data sources is hosed or stuck or has a quality problem or something we have to fix. And because it's stuck, we have to hold the entire data pipeline. We can't run anything, right? And so the entire system is like paused waiting because this really early join that's very, very critical that must happen before literally everything else can happen. At Slack, we had an in-house experiments framework. We wrote our own like framework for A/B testing things and stuff like that, right? And the experimentation system is almost always like I don't know how it is for y'all, but like at Slack, every data pipeline fed into the experiments pipeline, like because the experimentation system was used for all product decisions because it, A/B testing revenue, A/B testing growth, all of this stuff all fed through the experiment system. And so the experiment system was there by definition the most delayed part of the system because any upstream issue would break it, right? So it's kind of like I'm trying to think what would be a good metric for this. I really am. It's more of like you want to be able to run as much of your data pipeline as possible when one of the sort of upstream sources is broken. Like what percentage of your data pipeline can run when the upstream system is this thing is hosed, this is offline. Like, and this is just, I'm saying this is like, again, I'm not like better than anyone else. I only know about this problem because it happened to me at Slack.
And you care, there's a lot of people saying that, oh, data quality, but
data quality, but like, again, like this is, I guess, I don't know. Part of my, like, the things I talk about, I talk about startups. I work at, startups is what I do. Right. And so my mentality is very much every day we are running out of money. Every day we are one day closer to going out of business. And so every day that we have to wait and cannot make a decision about something that will potentially make us more money or make our users happier is another day closer to death, basically. That's kind of a dark existential take on startup life in San Francisco, but that's just how I think about these things. Yeah, it bothers me. It does. It absolutely bothers me, no doubt. Time is everything. Yeah, absolutely. Yeah.
Anyone has a question? Anyone?
Yeah. Hey.
Josh. Yeah.
Yes.
Thank you. I think your talk really awesome. Yeah. I want to ask. Did you agree the data contract? It need to maintain because we are working on a schema on write, for example, PostgreSQL. Because this is my first question. Did you agree? Because we use schema on read, so we need to solve this maintain data contract.
I mean, I guess I don't. We need some way of doing this. I think like we need some. The point of data contracts for me is to cheaply verify that an upstream change will not break a downstream data pipeline. That's sort of the goal. Like most people don't have data contracts. Data contracts don't exist most places. Most people like, I change my upstream system and I don't care what happens downstream. Salesforce is probably the worst offender in this regard. If I had a nickel for every time like a Salesforce administrator made some small change in the user interface that completely changed the downstream data schema that Salesforce would send to the data warehouse, I would be retired. I don't know. I'm not sure what it would be. Anyway, yeah, that's sort of the main reason. I don't like the schema on write part. I don't follow. Like I guess I don't quite get what you're saying. Yeah.
Yeah. Because the following question, because I'm thinking, if I can use like data lake house that use concept like schema on red.
Yes.
So I can get rid of about maintain schema. I can forget. I can decrease the influence from the upstream. Yeah, because I was experienced the whole you was mentioned containerized and the CI/CD and testing and data quality. So I just wondering if there a new system I can choose. I use a traditional structured database, or I can use directly about lakehouse, so I can forget data contract because I used schema on red. Yeah. Did you agree?
I don't feel like schema on read saves me from the problems I'm talking about here. Yeah. I'm trying to think. The thing where things tend to go wrong is that even when I do schema on read, there is some code that expects a schema. Like I'm telling it the schema. Like when I do schema on read, I'm saying this is the schema I expect, but I may not get it back, right? Like the virtue of schema on write is that I know at the time I write the data that it had this schema. I know this.
Yeah.
Whereas with schema on read, the data was written. I don't know what schema it had. I can propose to the data, hi data, I would like you to have this schema. It might have that schema. It might not have that schema. Nothing is really enforcing that schema when I do schema on read. And so I don't know. I have personally like soured. I don't like schema on read anymore. I like schemas. I really do. I like types. I like consistent naming. I like all of this stuff a lot because it makes my life much easier in the grand scheme of things. Yes, I am very much a proponent of these things. Yeah.
Yeah, cool.
Anyway.
I think you just mentioned. I think you inspire me to don't forget the there's still somewhere need to
consume it, read
the
it,
schema,
understand it.
Yeah. So
exactly.
I think it's just probably different place is suitable for schema on read.
Indeed.
Yeah.
I mean, I say this is like there's still very much places for schema on read. I guess what I have found is that every database table I have ever created has had a column that's named like extras or JSON or other stuff.
Yeah.
At Slack, I actually had I named it a kitchen sink. That was actually what I called it. I called it kitchen sink. Everything in the kitchen sink. And the kitchen sink, the extras, is where developers were allowed and in fact encouraged to throw in any data they wanted. Anything. It was just JSON. Could be anything they wanted it to be. And what would inevitably happen is some developer would randomly add a field to the extras data, and somehow that field would become incredibly important to some machine learning model or some business process or something downstream. Inevitably this would happen, right? Every single time. And that's good. That's a good thing, because if kitchen sink wasn't there, we would have never captured the data in the first place, which is good, right? That is a schema on read situation, because the only promise I make when I write the data is that the field will be JSON. That's the only promise I'm making, right? Nothing else, no types, no names, anything like that, right? So there is very much a place for this kind of thing. It's good that we have these kinds of things, like the schema on read, throw anything you want in there, it's completely fine. But it shouldn't be our strategy. It should really be the exceptional situation is kind of my preference here. Yeah.
Yeah, cool.
Yeah, cool. Great question, man. Thank you. Yeah.
Any other question? No? Then I think we can take a picture and then let Josh can continue the pizza.
Pizza. I'm so hungry. Thank you very much. Cool.